You know that feeling when you get a brilliant idea for an invention, like a robot or some kind of smart home gadget, maybe even your own personal arcade machine? Well, the power to actually build that stuff is way more accessible than you think. And it all starts with this tiny, super powerful computer that's honestly changed the game for makers everywhere.
It's pretty wild to think about, but the very first computers were absolute monsters. We're talking colossal machines that took up entire rooms and needed whole teams of people just to run them. They were powerful, for sure, but they belonged to governments and giant corporations, completely out of reach for regular people.
Okay, now let's fast forward to today. Everything has changed. We've got computers so small and so cheap, you can literally hold one in the palm of your hand. And there's one device in particular that has totally revolutionized what's possible for students, hobbyists, and inventors, and that's the Raspberry Pi. See, this isn't just about shrinking technology. It's about making the act of creation available to everyone. The Raspberry Pi isn't just another piece of hardware. Think of it more like a blank canvas for your imagination. So what is it exactly? Well, imagine a full miniature computer. The Raspberry Pi has a processor, memory, and all the ports you'd expect, just like your laptop, but it's stripped down to the absolute essentials. This makes it the perfect brain to power whatever custom project you can dream up.
Now, if you've ever messed around with DIY electronics, a question might be popping into your head. Wait, what about Arduino? And that's a great question. It's probably the most common point of confusion for beginners, so let's clear that up right now. Figuring out the difference between these two little powerhouses is really the key to picking the right tool for your project. And listen, it's not about which one is better. It's all about which one is right for the specific job you have in mind.
Okay, the absolute best way to think about this is with a little analogy. The Raspberry Pi is the brain, right? It runs a full operating system, it can handle multiple tasks at once, and it's perfect for more complex stuff, like projects that need to connect to the internet or process video. The Arduino, on the other hand, that's the reflexes. It's a microcontroller, which means it does one thing, and it does that one thing incredibly well. It just runs a single piece of code over and over again, which is perfect for simple, repetitive tasks like blinking a light or reading a sensor. Brains and reflexes.
So, you've decided you need the brain power of the Pi? Awesome! Getting it up and running for the first time might sound a little intimidating, but I promise you, it's actually super straightforward. It really just boils down to three main steps. First, you'll put the operating system on an SD card. This little card acts as the Pi's memory. Its hard drive, the whole shebang. Second, you just plug in your stuff, a keyboard, a mouse, a screen. And third, you plug in the power and watch it boot up. You'll see a desktop just like any other computer.
Once you're in, it's time to actually tell the Pi what to do. And the best part is, you don't have to be some kind of coding wizard. Languages like Python are incredibly easy for beginners to pick up, but they're also powerful enough for really advanced projects. And for total beginners, or even for kids, there's Scratch, which is a visual way to code by just snapping blocks together. It's awesome.
Okay, this is where things get really, really cool. A computer's great, but a computer that can actually interact with the physical world around it, that's where the magic is. And to do that, we need to give our Pi some senses and some muscles.
First up, we've got to give our Pi senses. And that's where sensors come in. These are little electronic parts that let your project see or hear or feel what's going on. They gather all sorts of data, like temperature, motion, light levels, you name it.
But, just sensing things is only half the battle. To actually do something with that information, your project needs muscles. We call these actuators. They take commands from the Pi and perform a physical action. Boom, light up an LED, whir, spin a motor, beep, make a sound. It's the senses and the muscles working together. So, a project that can sense its environment and then react to it is already amazing. But what if that project could communicate with other devices, and even the internet? Well, that just opens up a whole new universe of possibilities. Your Pi has a bunch of ways it can talk to the world. You've got your standards like Wi-Fi and Bluetooth, which you already know. But then there are these specialized protocols. MQTT, for example, is like a super efficient, lightweight whisper that lets smart devices chat with each other without using a ton of power. And LoRa is for sending tiny bits of information over really, really long distances. Each one is like a different kind of voice, and picking the right one is crucial. So, when you take a brain and you give it senses, muscles, and a voice,
You're stepping into the incredible world of IoT, the Internet of Things.
Put simply, the Internet of Things is just this giant, growing network of connected, well, things. Everything from your smartwatch to giant factory equipment, all of them embedded with sensors, gathering and sharing data. And your little Raspberry Pi is the perfect tool for you to build your very own thing to add to that network.
Let's make this real. Let's build an idea together right now. We start with our Raspberry Pi. That's the brain of our operation, ready to process information and make some decisions. Okay, next we give it senses. Let's add a simple moisture sensor that we can stick in the soil of a houseplant. Its job is to constantly check how wet or dry that soil is.
Then, let's give it a voice. We'll connect our Pi to our home Wi-Fi network. Now it has a way to send messages out into the world.
And when you put it all together, the brain, the senses, and the voice, what do you get? You get a smart plant that can send a message right to your phone that says, "Hey, I'm thirsty." How cool is that? It's simple, but it's powerful and genuinely useful. And honestly, that is just scratching the surface. You could build a full-on home automation system to control your lights and thermostat from your phone, or a smart weather station that posts live data to a website, or, yeah, a retro gaming console to play all your favorite classic games. You could even build an AI-powered smart mirror that shows you the news while you're brushing your teeth. The possibilities are nuts. When you have a tool this flexible and this powerful, it all comes down to this one simple truth. The hardware and the software, they're just the building blocks. The real creative spark, that comes from you.
So there you have it. We've looked at the brain, the senses, the muscles, and the voice. You now have the fundamental pieces to build just about anything you can dream up. So the only real question left is, what are you going to create? What problem will you solve?